In 2026, the traditional organic index serves as the baseline for visibility. It is the raw data set from which all search features are built. This comparison chart shows the immediate pressure on that baseline. On the left, standard blue links are being displaced. On the right, data shows AI overviews now intercept 25% of queries, triggering a 34.5% click-through rate drop for the top organic result. The competition for the remaining clicks is mathematically steep. Currently, 96.5% of all indexed pages receive zero traffic from Google. However, brands successfully cited within the AI overview see a 35% increase in organic clicks. These visits are characterized by 41% longer durations on site compared to standard organic traffic. Securing these citations requires aligning the site's technical configuration with the specific extraction requirements of large language models. AI visibility is a function of rigid machine-readable infrastructure. When the underlying plumbing is optimized, the models can identify and surface content with high confidence. We can identify these requirements by examining a successful brand citation inside a production AI overview. The code behind this link reveals a specific reliance on JSON LD FAQ page schema markup. Most SEO teams abandoned this markup in 2023 when Google restricted FAQ-rich results for most commercial websites. While those visual snippets are gone, the underlying need for structured data has intensified. LLMs utilize the Q&A format to instantly extract, to strictly verify, and correctly cite answers without generating hallucinations. This bar chart quantifies the impact. Pages utilizing FAQ page markup are 3.2 times more likely to be cited in AI overviews than those relying on unstructured text. This logic extends to e-commerce. Specific properties like hasVariant allow AI shopping graphs to parse complex product catalogs and present them as direct answers. Structured data now functions as an invisible API layer. It is the primary mechanism for delivering brand expertise directly to the machines. The site must pass through the two-wave render model. First, Googlebot instantly parses raw HTML for metadata and links before any JavaScript executes. The second wave is a delayed queue, waiting for the headless Chromium engine to render the final visual state. If your critical SEO elements, like canonical tags or schema, depend on JavaScript to load, they are pushed into this queue and often missed entirely. This delay creates a specific risk. If a no-index tag is found in the initial Wave 1 HTML, Googlebot may skip the second wave entirely, ignoring any JavaScript meant to remove that tag later. Maintaining visibility requires the use of server-side rendering or hydration, ensuring the complete indexable DOM is present in the initial server response. AI extraction bots prioritize speed. If your content is not visible during the first wave of rendering, it effectively does not exist to the systems generating citations. Performance has moved beyond the initial load. Success now requires maintaining a seamless mechanical response throughout the entire page lifecycle. This timeline comparison shows the shift in measurement. On the left, the obsolete first input delay only tracked the initial click. On the right, interaction to next paint monitors latency across every scroll, toggle, and interaction. Google measures this at the 95th percentile. To pass, interaction latency must stay below 200 milliseconds throughout the session. This performance level directly influences bot behavior. Googlebot ignores crawl delay instructions. Instead, it determines its own crawl rate based on the speed and stability of the server. When a server shows persistent 500-level errors or high latency, the bot registers a lack of capacity and throttles its activity. Unoptimized infrastructure acts as a physical barrier. It signals search engines to stop reading your content before it can even reach the extraction phase. Managing these bot interactions now happens through the robots.txt file, which has become a primary policy surface for AI crawlers. Webmasters must now issue two distinct directives: which content is open for traditional indexing and which content is available for AI model training. Implementing these policies often requires immediate changes that are frequently blocked by development backlogs and long sprint cycles. This map shows how Edge SEO bypasses these bottlenecks. Localized CDN nodes intercept requests and apply logic before reaching the origin server. Edge workers let teams instantly inject schema, modify headers, or correct redirects, detaching technical SEO from the core codebase. This creates a layer of operational agility, allowing brands to update their bot policies and technical configurations in response to real-time search shifts. This pipeline diagram assembles the reverse-engineered stack into a single sequence of technical requirements. Success is the result of data passing cleanly through each gate, from robots' authorization to edge delivery, through the first wave of rendering, and finally into the extraction layer. Standards like HTTPS and mobile-first responsiveness have reached 98% adoption. They are baseline requirements that no longer provide a ranking advantage. The 2026 competitive moat is built on the 53% of websites currently failing core web vitals. Flawless INP scores and schema formatting are the differentiators. Modern technical optimization is the engineering of a high-speed data architecture. It ensures that diverse AI models can extract and cite brand expertise with